Hey guys, in this video I'm going to discuss example 5.27, and it says that for any continuous distribution, show that the mean deviation is the least when taken from the median, right? In the previous video I discussed CDF, cumulative distribution functions, and how it works, and a few examples here and there. So now let's just start with this example. It is a proof. I'm going to repeat myself. Show that the mean deviation is the least when taken from the median, right? So for solving this, I'm going to take a function ma, right? Or let me just remove this. Yeah. So fx is my PDF. fx is PDF where my x lies between any two values a and b. Right. Now I'll define a function ma, which is the deviation of x from the point A, where A is any point lying between A and B, right? So capital A is any point lying between A and B, right? So I am MA is a function that is defining the deviation of x, this random variable x, from this point A, which lies between A and B, right? And my limits will be small a to A and capital A to small b. Now I'm writing this as two different functions because I have a mod sign here, right? So the function x minus a fx dx. The formula for finding the deviation is x minus a fx dx, or let me just write this clearly on the next page. Wait, let me just use my eraser. So this is x minus a, this is x minus a fx dx plus capital A to small b x minus a fx dx. Now I'm writing this as two different functions because the value of x minus a, mod x minus a, will change, right, around the point capital A. Or let me just show you guys. So if my function is mod of x minus a, I can define this as x minus a when my x is greater than equal to a, and negative x minus a when my x is less than a, right? So now my ma is small a to capital A. Now this will become, this integral is, we are taking the limits where my x is less than a, right? So when my x is less than a, my function will become my x minus mod a, x minus a mod will become minus x minus a fx dx, right? And this function will remain as it is because my domain here is x greater than a, right? This domain, wait, not this domain, this domain, right? So my function will become a to b, x minus a will remain as it is because this is positive, so this will become fx dx, a to b x minus a fx dx, right? So now this is my function for finding the deviation of x from any point A that lies between A and B, right? So now we need to find the value of A, right? And also for finding the least value, for example, let's just suppose that A gives me the least value of the deviation from x, right? So my question says that we need to show that the mean deviation is the least when taken from the median. Let's just suppose that my mean deviation is the least when taken from point A, right? But to prove this, I would need to prove that my del ma upon del A is equal to 0, that the point A is a stationary point of ma. And the second thing that I would need to prove is right, Why? I need to prove that A is a stationary point, and I also need to show that this is a convex function, right? And if it's a convex function, then we'll be getting we can include that the value of A is giving me the least value, right? Let me just see if I have written this correctly. Yeah. So let me just explain this point again. Right. So what this implies is that if this is my real line and I have a function ma, right? So if A is giving me the least value of ma, then my m dash a should be 0 at point A, and also my ma should be a convex function, right? This will prove that A is a local minima in the interval A and B, right? So let's just find the first derivative, del ma by del A. So now we need to find, and my ma was small a to a, negative, I am taking out negative, x minus a fx dx plus positive, or let me just in the next step I am going to multiply this negative inside, or let me just remove this negative. I just multiplied the negative inside and I got a minus x instead of x minus a, right? Capital A to B. Right. So this was my function, or I can just show you, right? This was my function. I just multiplied negative sign inside, so I got a minus x fx dx from small a to capital A, and capital A to B I have x minus a fx dx, right? I just wrote this in the bracket. So now let's just move to the next slide. So I need to find the derivative of this whole function ma, this whole expression with respect to a. So now I'll be writing one formula. Whenever we have any function fx comma theta dx, where the limits are, for example, from small a to small b, where a and b can be anything, this is just a formula, right? And we need to find del by del theta, right? So the formula is, for finding the derivative, the partial derivative of this expression with respect to theta is find this is a to b, yes. So find del f by del theta, yeah, and then find del f by del theta dx. So then add f. Now substitute b in place of x, right? B comma theta del b by del theta, and subtract f a comma theta, or let me just move to the next line. Now subtract f a comma theta del a by del theta. Find the integral of this whole expression then, right? So let's just define a function g x comma a, right? So g x comma a is, in our case, I am finding the value of the first integral here, a minus x fx dx, right? So firstly let me just show you. Wait, this is our formula. Right. So now we need to calculate del. We want to calculate del ma by del theta, which is equal to del by del theta, and this whole expression, small a to a minus x fx dx plus capital A to small b. Now this small a and small b are different, right? These are just I'm using this small a and small b just to denote the formula, right? So now I have x minus a fx dx, right? Yes. So now I am going to find the value of this first expression. So for finding the derivative of the first expression, so del by del theta of a to a minus x fx dx, right? I am going to apply this formula. So I am going to define this a minus x fx as gx comma a, right? So g x comma a is equal to a minus x fx dx. Fx is a minus x fx, right? Now if I apply my formula on this expression gx comma a by del d by del a gx comma a, this will become small a to capital A, small a to capital A. These are my limits, and see, these were my limits, small a to capital A. I am finding the partial derivative with respect to a of this first expression, right? So our theta is a here, right? I am going to replace this, right? So my theta is a here. Let me just remove theta from all places. We need to find del ma by del a. This is del a, this is del a. This is the value, we are finding the first integral, right? So gx comma a, so my formula will become del g by del a dx positive f. Now b is my a, right? So this will become f a comma theta, the upper limit, right? Not b, the upper limit, right? We need to substitute the upper limit in place of x. So this becomes f a comma a, g a comma a, just replace a in place of x. So this becomes g a comma a, and find del a by del a, right? Then subtract g, this lower limit comma a, del small a by del a, right? Now del small a by del a is equal to 0, right? Because a is a constant term, so our expression will reduce to this small a to a del g by del a dx plus g a comma a del a by del a, right? This is 0. Del small a by del a is 0, right? Now let me move to the next slide. Yeah, so my expression reduces to a to a del g by del capital A dx plus substitute the value of a in place of x. So a comma a del a by del a, right? Now g a comma a is g x comma a was a minus x fx. So if I substitute a in place of x, I will be getting ga comma a minus a, fa. So this will become 0, a minus a is 0. So my second term is also 0. So what I will be left with is small a to capital A del g by del a dx, right? So my del g by del a will become, so if my function is a minus x fx, gx comma a is a minus x fx, so let me just erase this, erasing this line and erasing this equal to sign, right? So if I need to find del g by del a, if my g x comma a is equal to a minus x is a minus x fx, then my del g by del a will become del g by del a. Del g by del a will become del g by del a, the partial derivative of g with respect to a. So this will become del by del a. So this is a fx minus x fx, right? And I need to find the partial derivative with respect to a. So my function will reduce to fx, right? And the second term is 0 because I don't have a here, right? So my function becomes, so my del g by del a becomes the derivative of d del a of a fx minus x fx, and I need to find the partial derivative. So I don't need to find f dash a and the whole expression f del f by del a, right? So in the normal course, if we needed to find d by dA of this whole function, in the normal course, if you had to find this expression, then you would have written this as, so this would have become d by dA, right? I'm just showing you the difference between del and d, right? So this becomes a fx minus x fx, right? And if I need to find the derivative with respect to a, not the partial derivative, the normal derivative, then my expression would have become fx, just applying the product rule, and a f dash x del f by del a, subtracting this from now del x by del a fx and x f dash x del f by del a, right? This would have become my whole expression, but we only need to find the partial derivative, and partial derivative says that our expression will reduce to, just find the derivative of the whole expression with respect to a and don't touch the other function. So this will be, this is 0 because this term does not have any a here. So this first expression, this first expression a fx will reduce to fx, right? And I am erasing this whole part. This was just to explain you guys. This was just for your explanation. I was just showing you the difference between the normal derivative and the partial derivative, right? So we don't need to touch the other function. Yes. So my function becomes fx, right? So finally the value of my integral becomes the value of del by del a, g of x comma a becomes small a to capital A fx dx. Now I am defining the second function, my second function as hx comma a. Hx comma a is capital A to small b x minus a fx see. Now we need to find the value of the second integral, right? So my second expression was find del by del a of see, here I represented this incorrectly. My gx comma a was a minus x, so this is, so I need to erase this. I don't have enough space. Let me just, this was the integral from a to a of, with respect to a, right? This was the whole expression from small a to a, right? Applying this formula will give me this. See, you can just see this formula, right? Yes. So now the value, the second expression that I need to find was, find from capital A to small b x minus a fx dx, right? Now let me assume this second function, this x minus a fx dx, as hx comma a. Hx comma a is x minus a fx, right? Right. Now see, hx comma a is the negative of gx comma a, right? So I can just, represent it in that way. I can just write a to a fx dx minus capital A to small b fx dx, because it's just the negative of gx comma a, the integral of gx comma a. But I'm going to show you all of the steps so that you don't get confused anywhere, right? So now we need to find, so my hx comma a is, x minus a fx, and we need to find the value, the value of the partial derivative of the integral of hx comma a, right? So what we need to find is, we need to find del by del a integrating from capital A to small b x comma a, hx comma capital A, right? So wrote this incorrectly. This is capital A, I'm so sorry, capital A. This is also capital A. Small a has gone. The small a was the lower limit. So this is hx comma a capital A. Just make it capital A. X comma x minus a. So this is hx comma a, hx comma capital A dx. Right. So the formula, if I apply the formula here, this will become the lower limit and the upper limit, and the derivative of h with respect to capital A, right? This capital A dx, then add h. Now substitute the upper limit in the expression in place of x. So this becomes h b comma a del h by h b comma a del b by del a negative. Now substitute the lower limit, ha comma ha del a by del a. Yeah. So find the integral of this whole expression. So what we will be getting is, now the value of hb comma a is, hb comma a will be b minus a f of b, right? And my del b with respect to a will be 0, right? Because b and a are constants, so this will be 0. So my whole expression h b comma a del b by del a will become 0. So my second expression, this expression is 0. This is 0, and my h a comma a is a minus a f of a, and this is 0. Therefore my third expression, which is h a comma a del a by del a, will also become 0, right? So I'll be left with del by del a from capital A to small b, from capital A to small b. I'll just draw a bracket here so that, or let me just write this more clearly. Del by del a, and this is a to b, capital A to b, h x comma a dx. This becomes del h comma del a dx from capital A to b, and all of the other expressions were 0 plus 0 and 0. right? So now my del h by del a is del h by del a is del my del h by del a is del by del a. My h is my h was my h x comma a, capital A, and this was del by del a. My h x comma a was x minus a, f x minus capital A. So sorry, this was x minus capital A fx. So if I just del h by del a, so this becomes del by del a x fx minus a fx. So this becomes negative of fx, right? So this is 0, and because we are finding the partial derivative, and this is my negative fx, right? So my expression del by del a of integrating capital A to small b h x comma a dx becomes, the value of this expression becomes the value of this expression becomes a to b, and I'm just taking out the negative sign, negative fx dx, right? So finally the value of this expression, del by del a, now I'm writing the whole expression from small a to capital A gx comma a dx, and adding capital A to small b h x comma a dx, the value of this whole expression, or the value of this expression what we need to find. So small a to capital A x minus a fx, this was a minus x, right? A minus x fx dx plus hx comma a, so x minus a fx dx, the value of this whole expression becomes small a to capital A fx dx, and negative of capital A to small b fx dx, right? So, and this whole expression was ma, right? This whole expression, right? Or let me just write, this was ma, right? So we were finding del m of a by del a, right? Del m of a by del a. Let me just show you. We need to find this, right? So my m of a was, yeah, this was ma, right? We need to find del m by del a, right? I'll just show you the value of ma. So this whole expression was ma, right? This negative of x minus a, negative goes inside, this becomes a minus x fx dx, right? So this was ma. So we need to find del ma by del a, and we need to equate this to 0, right? So now we'll be equating this to 0 to find the stationary point, or we'll find the point where the slope of ma becomes 0. So this is equal to 0, right? So now del m a by del a is equal to 0, this implies that this is 0, this implies that del, this implies that this small a to capital A fx dx and negative of capital A to small b fx dx, this is equal to 0. Now earlier I defined m of a as small a to a fx dx plus, or let me just remove all of this, wait, this is fx dx, right? So this is equal to 0, right? This is equal to 0, this whole is equal to 0. Now if I just take this to the RHS, this becomes a to a fx dx, and this becomes a to a b fx dx, right? And we know that the property of median says that if let point C be the median, so the property of median says that from the lower limit to C, if I integrate the PDF, the value of this expression will be equal to the value of the integral fx dx from C, which is the median, to the upper limit, that is infinity, if my x lies between negative infinity and positive infinity, right? So here what is happening is, from small a to capital A, fx dx is equal to integrating fx dx from this capital A, which is the lower limit in this case, to the upper limit b, right? And my x lies between a and b, so I can write this as, if for example in this question my lower limit was small a and let my c be the median, so if any time I have an expression like this, I can conclude that c is my median, right? This is the property of median. So my upper limit is b in this case, and this is fx dx, right? Now you can see that c and a are equal, right? This is the formula for finding the median, right? Where my lower limit is negative infinity and my upper limit is infinity. And in our case, the lower limit is small a and the upper limit is capital B. Our lower limit is small a and our upper limit is small b, right? So if any time I have an expression where I integrate the PDF from a to c, and this is equal to the value of the PDF when I integrate it over c to b, then I can say that c is my median, right? And you can see above that this is happening when I integrate the PDF fx from small a to capital A and then from capital A to b, right? This proves that a is our median, right? So when we have an expression like this, small a to capital A fx dx, and the value of this expression is equal to capital A to small b fx dx, then we can imply that a is the median, right? Now we have proved that a is the median, right? Now I need to prove that a is the minima, is the local minima in this case, because we are talking about a fixed interval, right, from a to b. So I just need to find del square ma by del square ma by del a square, and if the value of this is greater than 0, then I can conclude that a is a local minima in the interval small a to small b, right? This is my lower limit for x and this is my upper limit for x. I am writing the local minima here. Why? Because we are talking about a fixed interval, right? If we were talking about negative infinity to positive infinity, we can talk about that also, right? I am just showing you for any interval for any interval, right? So a and b, we don't know the value of a and b, we are just assuming a and b, right? So if a, the median is turning out to be the least, the value of the deviation of x, any point x lying between a and b, the value of x, the deviation of x from any point a, which is the median in any fixed interval a comma b, is turning out to be the minimum, then we can conclude that over all intervals on the real line, we can conclude that anywhere if we have the median, the value of the mean deviations will be the least, right? So I need to find the second derivative, right? And m del ma by del a was a small a to capital A fx dx, and negative of this from capital A to small b, capital A to small b fx dx, right? And I need to find the second derivative, right? So del a by del m of a del a, so this becomes del square ma by del a square, right? Or del a whole square. So now this was equal to 0, right? Now I know the value of the limits of x is from a to b, right? And we also know that if I integrate fx dx over the lower limit and the upper limit, we will get the sum, the value of the whole integral as 1, because this is the total area. The total area under the curve from the lower limit to the upper limit is equal to 1, right? So this a to b fx dx, I can just divide this into two parts, from small a to capital A fx dx, because capital A also lies between a and b, right? Because capital A is the median. So from a to b fx dx, and I can write this as in this way, and this is equal to 1, right? So now the value of small a to capital A fx dx becomes 1 minus small a, or the value of this capital A to small b fx dx, just taking this first expression to the RHS, so this becomes 1 minus small x to capital A fx dx, right? So del I can write del m of a by del a as small a to capital A fx dx, and now the value of the second expression becomes 1 minus, this was negative, right? So this was negative, so this was negative of 1 minus integral capital A 1 minus integral small a to capital A fx dx. And this was equal to 0. This is equal to 0. Or we were just equating it to 0 because we need to find the stationary point. This is not equal to 0 right now, right? This is not equal to 0. We were just equating it to 0 to find the stationary point. I'm so sorry, this is not equal to 0. Yeah, so del m, del m of a by del a becomes 2 times small a to capital A fx dx minus 1. So this whole expression gets reduced. So this whole expression gets reduced to, so wait, let me just, yeah. So this whole expression gets reduced to del, yeah. So the value of my second derivative, right, del a square becomes 2 times the derivative with respect to a of this expression, right? And if I just apply the Lebanese rule here for one variable, so I'll be getting so this a to a fx dx becomes d by dA. So not d by dA, del by del A. Let me go to the next slide. So the value of this becomes del by del a small a to capital A fx dx, right? So this becomes f of capital A del a by del a, and subtracting this becomes f of small a by del small a by del capital A, right? This is the formula for the Lebanese rule in single variable. So this becomes so del a and del a goes away, and del small a by del a capital A is 0 because small a and capital A, both of these are constants, right? And del a by del a gets cancelled. We are left with f of a, right? So finally my value del square m of a by del a square becomes 2 times f of a, right? Which is greater than 0. Why? Because f of fx is my PDF, and I substitute a, so it will give me the probability at point A, right? And assuming that f of a is not equal to 0 at the median, right? If it was a symmetrical distribution, I guess it can be 0, but yeah, we are assuming that it's not. This is debatable, but yeah, assuming that this is greater than 0, so because fx is just giving me the fx is the PDF, right? And fa is just giving me the probability at the point A. At or just integrating this. This is the continuous distribution. We are talking about continuous distributions. So I won't be saying like f of a is giving me the probability at point A. This will denote f of a is basically the probability under the curve from lower limit a to the upper limit capital A, right? So this is 2fa, this is greater than 0, right? So what we got is del ma by del a is equal to 0, and this proved that a is the median, and when I checked the second derivative of del ma by del a square at the point A, obviously at the point, and when I check del ma by del a square at the point A, I got this as positive. Yeah, this turned out to be positive. This implies that A is the local minima in the interval in A, B. I can also say that this is a global minima in A, B. Why? Because this is an interval, right? So I don't need to write if it's a local minima or a global minima. But usually when we are talking about in this particular interval, I can say that it's also a global minima, right? I can also say, I can say that in the interval A, B, it is a global minima. Earlier I told you a different thing. But yeah, in a specific interval, when we are talking about a point which is turning out to be a local minima, if we were talking about from negative infinity to positive infinity, A would be any A which is a stationary point, and we are getting the second derivative to be positive at that point as positive, then we can say that A is a local minima. If we are talking about the whole real line from negative infinity to positive infinity, we can say that it is a local minima, because we don't know if there is any other point. But in this specific interval from A, B, this can be, we can say that it is a global minimum in a particular interval, right? So let me just remove this is the minima. Let me just write this as this is the minima. Also, this is part of optimization and calculus, right? So you need to check those out on your own. I'm not going to discuss that any further, right? So I'm just removing the word local from all of the slides. Let me just remove this. This is a minima in a particular interval. I'm not writing the word local here. I'm removing the word local here. Why? Because in a particular interval it can be the global. It is the global minima, right? Yeah. So what we did was, let me just go through the whole whole procedure, right? So what we need to find was for any continuous distribution, show that the mean deviation is the least when taken from the median. So we assume that fx is a PDF where x lies between a and b, and capital A is any point lying between a and b, right? So what we did was we just defined ma as a function, and ma is telling us the value of the deviation from x, or the value of the deviation of x from the point a, which is lying between a and b. So the value of this will be the mod of x minus a fx dx, and I just separated this into two different integrals. Why? Because x minus a, this is a mod function, right? And this will be positive when taking the value of x greater than a, and will be negative when taking the value of x less than a, right? So then we just differentiated del ma with respect to a, right? And I solved this using this formula, right? This is the Leibniz formula only for a function of two variables, right? Yeah, then I applied this whole formula, and after applying this whole formula, these were all the steps. This is the second step, and this was the third step. So applying all of the formulas, what I found in the end was del ma by del a is a to a fx dx minus capital A to b fx dx, which and then we equated it to 0, right? We equated this to 0, and this turned out to be equal, right? And this implies, this whole expression implies that capital A is the median, right? I wrote the property of median below, so you can check it, right? In the next step, I found the second derivative. In the next step I found right, wait, let me just go downwards. Yeah, so in the next step I started solving the second derivative, right? So for finding the second derivative, first of all, what I did was I used this property. Wait, I used this property, the property of PDF. Integrating the value of the PDF from the lower limit to the upper limit will give me the value 1, because it will be the probability under the whole curve, right? And then what I did was I applied this property, right? I used this property, and then I substituted the value of fx dx from small a to capital B, from capital A to small b, in my first derivative, in the expression of my first derivative, which gave me the value of the expression as del ma by del a as 2 times small a to capital A fx dx minus 1. Then I found the second derivative. Finding the second derivative with respect to a gave me the value as 2fa, and which is positive, obviously, because fa is the probability under the curve from the lower limit to the point capital A, right? And probability is always positive, so 2 times fa is positive, which implied that first of all, a is a stationary point, because we equated this to 0, and equating it to 0 also told us that a is the median, right? So a turned out to be the median, and secondly, because the value of the second derivative was greater than 0, which means that it is a convex function, and a is the minimum, right? Because the stationary point of a convex function is always a minima, right? And this essentially proved that a is the median and is minimizing and is a is the median and is minimizing a is the median and is minimizing the expression ma is equal to small a to b x minus a fx dx. This means that for any continuous distribution, the mean deviation is the least when taken from the median, because ma is the expression that is denoting the mean deviation from the variable x, right? This was our whole proof. I hope you guys got some idea of what I'm explaining. Again, I am thinking that you might be getting a lot of doubts in this. So if you have any doubts or you want me to explain this again in some other video, I'll be doing that. I hope you guys like the video. If you like the video, just subscribe the channel, share the video, and put in some comments. It will encourage me to put on more videos. So thank you. I hope to see you in the next video. Right? Bye bye.